CSIM Core 2 has a lot of different options in nuclear magnetic resonance. We have very nice 600 megahertz spectrometer that we use for in full automation with sample changers that we can measure many different samples, and we can do routine analysis, proton NMR, 2D NMR. In addition to that, we have some unique equipment that is really one of a kind in the world. We have a small volume probe in a different 600 megahertz instrument, so it's good for sample limited cases, and it's optimized for C13 detection. We have a third instrument that we can use for tissue analysis, where we can take chunks of tissue and actually look at them directly without any extraction and very rapid measurements. And this provides a great deal of information that we couldn't get with other methods.
My role in Core 2 is really the development of C13-based NMR methods. So one of the major projects that I'm working on is actually doing inadequate mixture analysis, and with several collaborations, we've managed to really automate the process of analyzing complex mixtures using inadequate, which gives the carbon skeleton of a molecule as well as chemical shift information, and is an incredibly powerful technique.
We're putting most of our efforts on C13 NMR, as well as getting the routine stuff more automated.
We're really interested in taking this technology to the next level in terms of studying metabolism in vivo. But I'm also working on a new technique called dynamic nuclear polarization. And what this essentially allows us to do is to take a molecule of interest that we know is important in a particular metabolic pathway and enhance its signal 10,000-fold, so that essentially we're searching for a needle in a haystack, but now the needle has a much, much stronger signal than any of the hay in which it's found, so we can track it in real time in a living organism.
We have the equipment to be able to provide the best C13 data in the world. So CSIM Core 2 is fully integrated with the other cores, and within CSIM we work hand in hand with Core 1 for routine service analysis. We're also working closely with Core 3 with the C13 work in Aroa. And then finally, Core 4, the bioinformatics core, is helping us with every aspect of what we're doing. They're helping us with automation. They're helping us make our in-house scripts more usable. And we think that combined with Core 3, which is developing Aroa, we really will have something unique in CSIM to offer to users. It's a very exciting time to be involved in metabolomics on a big scale like this, because a lot of things are being developed, and it's still in its infancy. There's a lot, we have foundations to stand upon, but a lot yet still to be worked out, which makes it an exciting area.